Okay, for number 2, I'm going to go to the whiteboard, and I'm going to do it. All right, nature of the roots. Cubic polynomial, let me write it down for you. The cubic polynomial is f of x equals x cubed plus 3x minus 5. And I have a general idea of the shape of it. I mean, something like this over here. I know there's at least one root. All right, now the question becomes, if you use Sturm's theorem, I guess that's appropriate. But the bottom line is, we're going to just go back to basic things. And the basic things I'm going to go to is, I'm going to look at Descartes' rule of signs. And what do I get? I get plus, plus, minus. All right? So s equals 1. So I have one positive root. All right, let me try to figure out where it is. F of 0 is pretty easy. I'm going to say it's a negative number. F of 1 is fairly easy. What would you get? 1 plus 3 minus 5. It's still a negative number. It's still below the x-axis, by the way. I'm using the intermediate value theorem to figure out when it pokes through. And I want to see when it pokes through integer-wise. What would you get over there? 8 plus 6. Oh, this is definitely positive. So I know there's one positive root. So that root, there's only one of them. So x, there's one positive root. And x has to be on the interval between 1 and 2. I know that much. All right? Now, I'm going to rotate the curve. And let's do f of minus x. We're still using Descartes' rule of signs. That's going to be minus x cubed, minus 3x, minus 5. And what do you get there? Minus, minus, minus. So s equals 0. So there are no negative roots. So there's one real root. That real root is on the interval between 1 and 2 complex roots. All right? So, looking at it, they're not asking really to solve it. At least I don't think so. Let me make sure to read that. It's number 2, right? Yeah, they're not asking that. They're not asking for it, all right? So we're not going to bother with that. But we've done that in the past, by the way. And the nature of the roots, again, one real root between 1 and 2, and there's 2 complex roots, all right? I want to go back to the picture. And let me just do that, and then I'll go back. And this is number 2. Again, Sturm's theorem is being done here. Again, I do say one root between 1 and 2 complex roots. And the picture, figure 369. That's the picture over here, all right? And we're done. Thank you.